Oké, goedemorgen iedereen, het is 10 uur. Ik zie dat er al een heel aantal mensen in de call zitten, dus leuk dat jullie op tijd zijn. We gaan er ook meteen aan beginnen. We hebben maar 3 kwartiertjes ingepland. Goedemorgen, welkom bij onze cloud-sessie vandaag, georganiseerd door Exclusive Networks en Nuaware. Ik ben Quinte van Exclusive Networks. Ik veronderstel dat iedereen Exclusive wel kent, als jullie IT-distributeur voor cybersecurity, oplossingen en networking. Maar wij werken natuurlijk dat de markt en het IT-landschap de laatste jaren heel erg evolueert in de richting van cloud. En dan kan security uiteraard ook niet achterblijven. Het is nog een heel andere uitdaging, cloud security, ten opzichte van de standaard netwerk security die wij kennen. Vandaar hebben we een half jaar geleden ongeveer Nuaware overgenomen, waar Exclusive eigenlijk de aangevende distri is voor cybersecurity, is Nuaware dat absoluut voor alles wat met cloud-native security te maken heeft. Dus eigenlijk door de handen in elkaar te slaan, zijn we nu één team en kunnen we eigenlijk al jullie vraagstukken rond cloud security mee oppakken en jullie daar volledig van A tot Z in begeleiden. Vandaag is een mooie kennismaking met de mensen van Nuaware. Mochten er vragen zijn doorheen de sessie, drop ze zeker in de question box die jullie op jullie scherm vinden. Gaan we ze proberen tijdens de sessie al zoveel mogelijk te bespreken. En als er nog een aantal vragen onbeantwoord zijn gebleven, dan bespreken we ze achteraf zeker. Voilà, dat is het voor mij. We gaan er meteen aan beginnen. En ik ga dadelijk het woord geven aan Patrick en daarna gaat Wiebe overnemen. Dus Patrick, het is volledig aan jou.
Okay, perfect. Dankjewel, Quinten. Just to be sure, we decided up front that we're going to do this in English and prepared everything in English. So if you don't mind, I'm going to continue in English as well, because otherwise I have to translate back into Dutch and that's not going to work for me. So let's get fired up. So today, almost any organization sees the demand on IT increase. We're seeing IT infrastructure as a commodity and as a cost center. Well, our focus is shifting towards the part of our stack that actually makes our money, the application. And that's all being driven by that digital transformation. Your company doesn't differentiate itself by the products or services that it delivers, but in the way that the user consumes those services. Users want on-demand, 24-hour access to your services and pay as they go. And in parallel, competition is getting more and more fierce. To be able to survive that digital revolution, we need to modernize our businesses. And unfortunately, this doesn't come without specific challenges. Your business is going to be under constant pressure of customer demand or trying to keep up with competition. And security is changing in a world where our systems have become more connected and more complex than ever. And trying to keep up with the business changes going on, your application team are going to demand more flexibility, more diversity in tools, and use of new technologies, which in turn is going to drive additional security challenges as well. However way you look at it, it will always be focused around 3 main pillars. First of all, speed to market. We need to be able to bring new features to our application in less time. We can no longer afford to go through weeks or months of testing before a new release can be deployed. Efficiency. Modern application architectures will allow us to update components individually, while APIs will allow us to loosely couple those components and increase compatibility. Extreme automation will take away a lot of the manual tasks, resulting in less failures and high execution speeds. So if you're able to automate the entire testing process, ultimately you'll be able to push new changes to production in a matter of minutes. Finally, resilience. While speed and efficiency are on anybody's radar, don't forget that when you're digitizing your business and the majority of your revenue starts to come from those digital services, any downtime of those services will result in serious revenue losses. And to monetize our businesses, we will need to modernize our applications. Some applications may never be capable of delivering your services in modern ways, while others may be perfect candidates for transformation. So make sure you identify all parts in your application landscape and prioritize them accordingly. Transform those applications to newer technologies and methodologies. Introduce agile development, break monoliths up into microservices, and architect your applications for failure. And to be able to reduce the dependency on the underlying infrastructure or technologies used, make sure you use modern packaging solutions to speed up deployment and make them more reliable. Again, all this with speed, efficiency, and resilience in mind. And to be really fair, chances are your developers are already doing this. They will probably have become more autonomous over time. They'll have reorganized their teams to become more agile in the way that they develop their applications. They look at new technologies and architectures to make their work easier, faster, and more reliable. There's a saying in IT that if you have to repeat something more than 3 times, it should be automated. And they probably have automated almost every part of the application delivery cycle. Application builds, dependency management, packaging in containers, deploying into test environments, integration testing, unit testing, etc., etc. It all happens in their so-called continuous integration and continuous delivery pipelines. From code to shippable artifact, it takes mere minutes instead of weeks. The result? Your developer team is capable of producing so many new artifacts that traditional processes in our IT environment just can't keep up. That speed and the delivery cycle, well, it's all useless if deployment to production relies on older and incompatible deployment tools. What if ops needs to test the application extensively first to see if it can run on their infrastructure, which of course is slightly different from our dev environment? And what if security manually needs to sign off on the application? Deployment is delayed immensely. How about that new feature that we need to ship to our competitors before our competitors come out with a similar capability? It's going to be extremely challenging to do that. And that is exactly why many organizations have started to adopt DevOps, breaking down the barrier that exists between dev and ops. Share skills and knowledge and restructure operations in such a way that ops starts working in similar agile ways. And over time, they will have introduced concepts like container orchestration with Kubernetes to be able to manage the lifecycle of application, not only at scale, but also through the entire delivery cycle, all the way to production. Or infrastructure as code is another example, being able to automate the deployment of infrastructural components based on declarative manifests, just like the developers have been doing for ages with source code and build definitions. Application deployment has become part of that delivery pipeline, which is now called continuous deployment. And from code to production now takes only several minutes as well. But as each application and its containers have their own life cycles, and developers have gained the freedom to import external source code and dependencies into their applications. Did you know, by the way, that in many cases, only 20% of the code in your applications are actually written by your developers? And in a lot of cases, traditional security measures are incapable of keeping up with that newly found speed of development and deployment. Your security teams are constantly trying to secure your environment while it is under constant change, just like changing the wheels on the car while it is driving. And as with change in responsibility that came with the adoption of DevOps, we see a change in responsibility in security as well. But before we dive into the responsibilities, let's have a quick peek at what a modern supply chain looks like. This specific example details a container environment, which is nowadays the most used type. We see that applications move through a so-called pipeline, which creates shippable artifacts that are capable of being deployed onto any Kubernetes environment. Change in an application only happens on the left side in the application source code, like it has been forever. And once a company starts to adopt DevOps, we see ops shift to the left side as well, basically describing every aspect of the infrastructure as source code. Hence the term shift left. Changes to the infrastructure happen in the build phase, just like with application. No one makes changes to artifacts or running infrastructure anymore. And as you see, security is of concern in all 3 stages of that supply chain, no longer just in the run stage. Developers are automatically downloading dependencies from the internet. Containers should be built around best practices. So how do we validate that those best practices are met? And what are our containers actually doing? How many different versions of those containers do I have running at any single moment? So at which team do we look in search for those responsible persons? Is it the security team? Well, they probably have been so overwhelmed with the amount of change and security alerts that their existing tooling is triggering that they truly don't know where to start. Is it the DevOps team? Well, they've relied on the security team for such a long time that it just doesn't come to their attention. And the developer? Well, software development is a pretty rare skill. A software developer with extensive security knowledge, almost impossible to find. And because of the ever-broadening landscape of tools and methodologies, the developer is probably too busy with keeping up with those than to actually worry about security as well. And before we know it, we end up with orphan security, where everybody knows that there is a shared responsibility, but no one takes action, simply because we either don't know or we expect somebody else to take ownership. So what we've seen ops make the shift to the left to form a DevOps culture way of working. This has resulted in a shared responsibility and ownership between Dev and Ops in regards to building, testing, deployment, and operations. And now it's time for security to make that shift to the left as well, so that it too becomes an integral part of the application supply chain. How and why is what I'll leave to Wiebe to explain in further detail.
All right, thank you, Patrick. That was a very good introduction about DevOps and security. First of all, a little disclaimer, I got a skate incident earlier this week, so my face is a bit damaged, so please bear with me. So let's now talk about DevSecOps in your organization. We're going to touch upon a different kind of challenges that we see in typical organizations, in the larger enterprise-related organizations. And we'll go through a lot of them to see what the impact on those challenges is on the different departments. So first of all, I would give a very, very important tip or a hint to the tech leaders. You really need to change the culture of your organization. And why is this important? Because culture has an impact on everything that happens on the infrastructure side, on the application side, on the security side, and on the best practices. As Patrick already said, everything will be automated. We will shift towards a hybrid and a multi-cloud environment. And in order to do that, you need to change the way you develop your applications. You will push them to production, teams will push them to production by themselves. And that mixed cloud, that hybrid cloud, together with your internal data center, that requires a change in thinking on how to deal with that. So security teams are not only focused on the on-prem data center, but also on the cloud. Then we are modernizing our applications. We're shifting towards microservices in which we break down monoliths into smaller components. We package them in containers, but we also have functions. And functions are like source code in the cloud without any containers or virtual machines. Basically, you don't see them, but they need to be secured. You need to change the way you think of that. And also the management need to change the way they support teams to enable those kind of new development methodologies, because that also changes. Then security is still an integral part of basically everything. There are so many moving parts that you can't let that checked by only one security department. And what happens is there will be a segregation of duties. Security becomes a responsibility of everyone within the software development chain. But in the end, there should be only the DevSecOps team that is really end responsible for it. But they can't do it on their own. They still need to have the security departments, the traditional security departments, to help them with that, because they require the knowledge in order to secure their applications the best possible way. And to make that a reality, they need to adopt practices, just agile practices and Scrum and Kanban, of course, shifting security left, as Patrick already said, but also site reliability engineering. And in short, that is a new, relatively new discipline to make sure that your application keeps on running while there might be disruptions in the cloud, built for failure, as we call it. And if we summarize all of this, the culture really affects all of those areas. And we're now building the car as you drive it, and security is always an integral part of it. If we zoom onto 4 most important pillars of DevSecOps, we see the organization pillar, the process pillar, the technology pillar, and the governance pillar. And for organization, it's most important to break down the existing silos, those isolated working departments, which communicate to the outside world or to other organizational departments, but are more or less on their own. We need to promote team autonomy, which means that the team is ultimately responsible for their security stuff. They should work in isolation with the help of others, but being on their own, being self-responsible for their software development lifecycle, basically. But in order to do that, we also need to change our processes. We need to constantly build, ship, and run software in small batches, in small iterations. It's not just creating a project up front, a project plan up front, and then wait for 6 months to do the deployment. It's about automating every step, and every single application or even a very small infrastructure component can be deployed multiple times a day. And therefore, you need to have technology and tools. You need to carefully select the technology and tools you want to use in your organization. You need to acquire knowledge on how to choose a tool and which requirements apply for that tool. And most of the time, it's not only a technical requirement. It's a very important requirement to also take a look at the business perspective here. It's about business requirements. And if we have that all in place, we can indeed shorten our life cycle of our software components, bring them to the market faster, and increase our efficiency. But what about the governance part? Because if we say decentralized teams will be the future, and there won't be a very single centralized security team, for example, what about governance? Who owns security risks? Governance is all about risk management, and we need to have tools and technology to facilitate risk management in an automated way. And therefore, we need to think of different aspects here. So if we now zoom onto the organizational pillar, it's a constant battle, a balance between business features and security efforts. If we tackle this, or if we see this from the left side, we should classify our data. And our data is basically wrapped within an application, so we should also classify our application. We need to distinguish core apps versus supportive apps. And that data classification, we can use a CIA rating, a confidentiality, integrity, and availability level for every application. And we can use that as a hook towards other systems. And if we use that as a hook, then we can see this from the business perspective, like which application really deserves the most attention when it comes to security risks. And when it comes to, for example, growing a team or acquiring extra security related knowledge. So here also the security department comes in. And with that in mind, there's a lot of companies that think, okay, we need to educate the teams. We need to make them security aware. We can give them training and education. But it also applies to the management. If the management doesn't think about security in a new way, then nothing will change basically, because they will be stopped. Teams will be stopped if the management doesn't think about security in an IT-driven way. We need to be an IT-driven organization that takes security really in an automated fashion. It's a constant balance, but this might really help. Patrick already showed a simplified pipeline of a software development lifecycle. And here you see in the middle, you will see local test, static code analysis, and dynamic code analysis. And those are the three most important security stages inside a software development pipeline. And every piece of source code is pushed through this pipeline from left to right. And the security related issues that are found during those analysis stages are fed into a security platform. And then there is a role for a security team, a dedicated security team that maintains that platform. And together with the knowledge that's in the mind of people, standards and guidelines, it creates collective knowledge. That collective knowledge is a result of all the pipelines and of all the security issues which are found. And with that in mind, the security team can also inform a security community. And of course, the DevSecOps members should be a member of the security community to learn from previous security results. They don't have to reinvent the wheel every time. If they take a look at the results and if they learn from existing solutions, reusing examples, reusing security solutions, they can speed up. And this is all about faster to market. And this process really helps here. And to support those kind of pipelines, we need to have the right set of technologies. As said, we need to have tools in place. And here comes a very different strategic decision to be made by the management. They need to choose between a pure cloud native security solution acquired from a cloud service provider, or they have to choose for a dedicated tool. But they don't have the knowledge to justify whether it should be the dedicated tool or the cloud native solution. So the security teams really need to help here to evaluate tools and evaluate services to choose the best possible solution and support the management to reach their goals, basically. It's also about functional and technical maintenance. Don't underestimate that, because the tool needs to be maintained on a technical level, but also on a functional level. And that all has to do with setting policies and rules and enforcing standards and enforcing guidelines. And that really limits team autonomy, because if you say you can't proceed with your security pipeline, with your software development pipeline, because of these kind of security risks, that deviates maybe per application. But you need to think of that. Maybe some other teams can go ahead because they have the knowledge, but there will be differences per team. So that's a constant question to enforce standards, yes or no. It's all about risk management here. Let's now take a look at two important concepts that we know in DevSecOps. And the first one is one that everyone and every firewall department, every security department or infrastructure department will understand. Let's talk about firewalls. We're not going to have a single security perimeter anymore. That will really change. Let's look at how it looks right now in an on-prem data center. So on the left side, you have the external, the bad traffic, the hostile world. And inside, on the right side, we have our trusted data center. You see traffic is coming into the firewall. The corporate firewall evaluates the traffic based on IP addresses, ports, protocols, etc. And then traffic is allowed or not. And once it is allowed and it passed that single security perimeter, then you can access your applications and your data. But that all changes, because in the cloud, everything is considered hostile. It's a zero trust environment. If we talk about microservices, then we see here, for example, we see the Kubernetes containers, we see a database, we have key management, we have data storage, persistent data storage solutions. Those components all need to talk to each other. And if we consider every single connection in the cloud as being untrusted, we need to have, let's call it conceptual firewalls in between all of those components. So the number of firewalls increases significantly, and there's no single centralized department that can check all of those individual firewalls. Imagine if you have like hundreds of applications with multiple components talking to each other. The network communication paths will explode, basically. So that's why authentication and authorization of applications and components will use identities, component identities, to authenticate themselves and to authorize themselves. It's not based on static IP addresses or whitelist or dedicated ports anymore. It's all about identities. And in order to capture all of those identities, they need to be unique. You need to have software in place. And therefore, the selection of a tool that can do that is very, very important. If we now move to the second DevSecOps concept, we also see a change in how we deal with vulnerabilities. In the past, there was the security department that chooses between go or no go for an application to go to production. But if we're now deploying applications to production multiple times a day, the security team can't keep up. So that's why we have decentralized management of vulnerabilities in the new world. But then the following challenge comes up. Since everything is source code, we're talking about application source code, also infrastructure as code templates, deployment scripts, cloud native services itself, but also third-party dependencies which get injected into your source code if you choose to use them. And everything is dynamic, which means it can come and go as we speak. Since the release frequency increases, then we get a lot of different components coming and going. And if you have so many teams, for example, if you have more than 50 teams, then what happens with your vulnerabilities? In the end, they will all drill down to the DevSecOps team because we say, okay, they are responsible for it. But what about risk mitigation there? What will happen if there are so many vulnerabilities? If you start scanning all of your components, what would you do if your screen turns red? And of course, then you know you scanned a lot, but do you know if you scanned every single workload in every stage of the software development lifecycle? You can't even count the vulnerabilities. You can't select them. You need to have metadata about it to justify, is that vulnerability bound to a core application or a supportive application? Should you calculate the risk score, or should you teach everyone about the risks? I mean, do you bring reports to the management? What about false positives? How do you deal with that? If you don't choose a tool carefully, and if you end up with a lot of false positives, for example, a password which is not really a password, but it should not be in your source code, then you're looking at stuff you shouldn't be looking at. And that's why, from the business perspective, there needs to be a careful selection of tools, but also on processes, how to deal with this, because in the end, you're too late. If you scanned all of this, and if teams are already moving to production, then you're too late. Your security risks are already there. So if you see in the previous list and everything is red on your screen, you can run away, you can flight, or you can fight and make a smart plan. So, and that plan should come from the governance side of things. Remember, this is the fourth pillar of the DevSecOps initiatives, basically, and risk management changes here. As said, it has a huge impact on development teams, but also on the Security Operations Center, on CISO, on first line risk, the management, etc. And in order to do that, if we talk about tools, without tools we can't do anything basically. You need to define the right owner. Should the CISO department or the SOC department be the owner of the tools? Or should it be a dedicated team that helps the development teams? How does that scale? You need to think of that. And what about risk itself? Are you sure it's a risk? We were talking about false positives here, but risks should also be determined in terms of business continuity, for example. For critical applications, even a medium risk can have a huge impact on an application, which in turns to have a very, very big risk on the average business continuity of that application. And if that application is connected to a lot of other applications, then business continuity is really at risk if there's a big problem here. And then risk management also changes to other teams basically to secure their applications, because otherwise we can have a cascaded effect. And in order to speed up, because in the end we want to deliver applications faster to the cloud, make them more resilient, as Patrick said, there's a change in the mindset for the CISO department, for example. They used to say no, because this, you can't proceed with your application. That needs to change to yes, you can, and we do these kind of measures to make sure your application stays secure, or that we detect vulnerabilities and security issues. We detect it in an early stage. And if that mindset changes, then we can actually speed up. And that has an impact on the culture of the organization. Remember, culture, checking all of those different pillars basically. And ultimately, we also need to reduce our waivers. It's easy to say, okay, I'll accept that risk because it's just medium or it's a high risk and we will solve that in, let's say, 2 sprints from now. But we want to reduce that because then we lose visibility of that risk. And then our governance part has a hole in it. So that's why we need to avoid that. So let's now present a very brief business/security checklist. First of all, if you encounter so many risks for specific applications, you should answer the question like, what is the business impact? What if you do proceed? What can happen? Threat modeling, for example, can help you here, or the other way around. What happens if we fix it? What will be the negative impact on the business? They will be stopped, your application can't proceed, you might miss an important marketing campaign. What does that mean to the proposed revenue? But on the other hand, you can answer the question like, okay, is this application used or at all? Do we really use that feature? You have to monitor that. And if, for example, a feature with a critical vulnerability is not used at all, or if the revenue is not large enough to basically spend time on that issue, maybe you should just delete that. But you need to check that with your business. And then it comes to the mind of developers and product owners. They need to be really security aware. A product owner should give you time to evaluate your security issues, but also feed that back to the business itself. And if we then talk about reusing existing security solutions, that's of course a very, very important aspect here. Because if everyone learns about security issues and tries to reinvent and tries to fix issues on their own, they might miss an opportunity to really speed up. So share that knowledge. Make risk management part of your DevSecOps strategy. Because if it isn't part of your DevSecOps strategy, you don't know how to deal with this. And everyone will be stuck in a certain area. And to help teams getting their security knowledge up to speed, basically, or increase their security related knowledge, you can help them to fill in a DevSecOps maturity model. And that would basically assess their knowledge and see where they are on the maturity levels. And that can also help the management, if you do that on a large scale, that can help the management to determine what the best strategy is to implement DevSecOps on scale. And finally, the last one, and I think that's the most important one, if we talk about risk management here, who owns that risk? We can say it's the teams, but in the end, it's a joint venture between all the teams, but it all comes down to the DevSecOps teams. And there is where it will end. So all of the previous examples drill down to that. You need to answer that. And it's easy to answer, but you need to fill in that responsibility, basically. And what we see in the companies that we are connected to is what are their DevSecOps criteria. And we see here 6 ones that are the most important ones. We have a bird's eye view of security efforts. They are looking at security from a very, very high level, but they're hunting down security issues basically, but they're also paying attention to lower level details. So they'll acknowledge this costs time and money to investigate security issues, for example. They take security very, very seriously, even for the smallest bits and pieces. And they use that information to make their high-level plans. They're also acknowledging to automate everything that moves. So for example, your application should move to the cloud. You need to do a cloud risk assessment. You always need to involve, for example, the Dutch National Bank or another national bank, the ECB, for example. You need to fill in a PIA document, a privacy investigation assessment, a change risk assessment. All of those processes, most of the time, they're still manual. And from that perspective, there's a lot of departments that are involved in this area. Management needs to acknowledge that that also should be automated, for example. And in order to speed up, those companies secure everything from the source onwards. They start with source code, moving towards their pipelines, and also secure their running environments and monitor that and log that. And if in case something bad happens, then they send back feedback towards other teams to help them fix issues in a runtime environment as soon as possible. So that's why that is very important. And if we have logging and monitoring in place, if we capture security issues from that area, we have to take a risk-based operations approach, basically. We take a look at monitoring and logging, log files and dashboards with risks and security risks as a centralized point of view. If we collect that from that perspective, if we focus on that and we use that information back and we share that with all the others in the organization, be open on that, provide success stories, remediations, examples, help everyone to share whatever is there, even if it's a critical risk in a critical application, that really emphasizes why that is very important. So the business goals also should support this, and there should be room to do that. And if that really happens, you can be successful with your DevSecOps implementation in your organization. All right, that's it for now. We are in touch with a lot of companies, so please reach out if you have any questions or give us feedback to this session. Thank you. This is it for now.
Thank you, Wiebe. That was a very clear and very good explanation. I think I hope everyone found it interesting. We have still one open question that hasn't been answered. And the question is, how can we manage decentralized vulnerabilities in a centralized way?
So if you want to manage vulnerabilities, I mean, if they're decentralized, right, they'll be pushed to a centralized tool. And what we see is that every DevSecOps team will get access to their own vulnerabilities. Perhaps it will be isolated from other tools. They will be, for example, grouped in a so-called security namespace within the tool, and they are able to fix their issues from the perspective of that tool. They would see, for example, solutions or upgrades for dependencies which have an issue. And if they have questions about it or they have doubts about whether it should work or not, they can, of course, try it out. But from that perspective, it's good to have a hook with the security team. So, for example, if they request help, they should click on that issue, and then there should be a notification to a security team, an automated security hook, of course. Perhaps a ticket should be created on the security board, on the board of the security team, and they can then provide feedback out that issue. And then there will be a collaboration, and in the end, that comes back to the centralized security tool, and then they can fix that issue. They then tick the box, and yeah, when the security department says, okay, that's great, we also approve that, then it's done, and then it's done in an automated fashion without having to wait for the centralized security team to take a look at their security issues in a later stage, basically. I hope that answers your question.
Okay, thanks, Wiebe. I'm sure it does. For the rest, no other open questions. I think we answered everything during the session. If there are any questions later on, please don't hesitate to reach out. We will send the recording of this session to everyone, so you also have our contact details. And unless Patrick wants to add something, I would like to thank everyone again. I hope you found this interesting, and hope to talk to you soon.